Hello everybody, welcome to today's workshop. This is part of our project, which is funded by Impact Water Arizona to co-produce water strategies by modeling multifunctional turfgrass and landscape alternatives. For this project, we are partnering with Design Convo to facilitate the workshop communication. We also engage with the ASU CREST team to evaluate our progress. By the end of today's workshop, a CREST evaluation survey will be sent to gather your feedback on how to improve our next workshops and enhance the values of this project to your work. This is a brief overview of the entire project, which includes three main phases. To start with, we will identify turfgrass to be removed, maintained, or enhanced based on water efficiency and the multifunctionality of landscapes. And accordingly, we will also identify landscape alternatives for turfgrass replacement and enhancement. This will be the goals of today's workshop, and we will co-develop the levers to evaluate and model multifunctional turfgrass and landscape alternatives. And based on the stakeholders' input we will collect after the workshop, in the second phase, we will map turfgrass functionality and estimate irrigation needs to evaluate the water saving and other outcomes. In the CREST survey, we will also ask you if you want to be involved in helping to make model decisions during this phase, and you can also reach out to Dr. Kelly Larson directly. At the end of this project, we will hold the second set of the workshops to discuss modeling results and co-develop an interactive GIS dashboard with stakeholders. This project will focus on the Metro Phoenix and the Tucson areas to identify the distribution of the existing vegetation, including turfgrass, tree canopy, and other vegetation like shrubs. We will build on existing vegetation classifications derived from satellite imagery, such as the work from Central Arizona Project, PIMA Association of Governments, and the Central Arizona Phoenix Long-Term Ecological Research. Non-functional turfgrass, or NFT, is an emerging concept to identify turfgrass that does not provide recreational benefits. Municipalities in arid regions are now trying to remove and convert NFT to conserve water. Here we refer to NFT definitions developed by the city of Tucson and listed some mappable attributes and contexts here, such as the slope and the size of a turfgrass patch, its distance to a street, its accessibility, and whether it's used for active recreation. In addition to water conservation and recreational values, we also include two important turfgrass functions, the heat mitigation and stormwater management, to improve the multifunctionality of landscapes. For the four objectives shown here, we will co-develop mapping decisions based on available data with stakeholders, such as the turfgrass characteristic and contexts, and the associated criteria and thresholds. And for this project, we will use the water use classification of landscape species method, or the WOCUS method, to estimate vegetation elder irrigation. As you can see from the flowchart on the left, this model is built on four main landscaping factors: the patch size, species factor, density factor, and the microclimate factor. Among these four factors, we will ask you your professional input regarding the patch size, species, and the vegetation density to develop landscape alternatives. For microclimate factor, we will compute it based on the existing LiDAR data. The turfgrass water estimates will use the existing turfgrass distribution from land cover classification as model input, and the two scenarios of turfgrass water use will be estimated based on with or without winter overseeding. To validate the model, we will work with the water provider to compare the aggregate level, like census tract level water use data, with the estimated water use demands. For the landscape alternatives, we will invite stakeholders to decide what the preferred patch size, species, and density are in different scenarios, and then we will calculate the outdoor irrigation demands accordingly. By comparing the water estimates before and after the replacement or enhancement, then we will be able to obtain the water saving capacity for each scenario. The WOCUS model will calculate the outdoor irrigation for each turfgrass patch to produce a turfgrass water use map. And based on the stakeholders' defined parameters, we will also create turfgrass functionality maps based on its recreational benefits, heat mitigation, and stormwater management. Then we will overlay the water use map and the functionality maps in ArcGIS to identify where to remove, maintain, and enhance turfgrass areas. For example, low water use turfgrass with high functions on other objectives should be maintained, and by contrast, high water use turfgrass with low functions should be removed and replaced with desert-like landscapes. For the turfgrass with medium levels of water use and functions, we will develop the enhancement scenario to improve their water use efficiency and multifunctionality. We will also decide how to classify low, medium, high levels of functions and water use during our mapping and modeling processes, and we welcome anyone who wants to involved in this process after this workshop. For today's workshops, we have two goals. The first goal is to prioritize and refine the attributes of turfgrass to be removed, maintained, or enhanced for 4 objectives listed here. And accordingly, we have prepared 3 activities to achieve this goal. The second goal is to identify turfgrass replacements and enhancements with main consideration on tree species selections and tree density and spacing. We also have 1 activity to gather your professional input regarding this. For each objective, we consider turfgrass attributes at 2 scales, the localized scale and the neighborhood scale. At the localized scale, we consider the characteristic of a turfgrass patch itself, such as the size, slope, land use context for each turfgrass patch. At the neighborhood scale, we consider the characteristics of the neighborhoods as a block group or census tract level, such as the percentage of turfgrass or tree canopy cover and the average daytime summer land surface temperature for each census tract. In the next 4 slides, you will see both localized and the neighborhood scale attributes we highlighted for each objective. Those attributes will be also the pre-developed post-it notes you will see in the mirror board during the activity 1 and 2. We will ask you to review them and provide specific input, but you can also add other ideas we didn't include it here on the blank notes. For example, for the objective of water use conservation, we will ask stakeholders' input regarding the turfgrass patch size, tree species, and tree spacing. These localized attributes are based on the available data and the WOCUS modeling components. As a neighborhood scale, we may consider the areas with high vegetation cover and high water use rates. For recreational benefits, we listed some turfgrass attributes and associated criteria and thresholds based on the NFT definitions we discussed before. For Activity 1, we will ask your input regarding what types of turfgrass, based on localized turfgrass attributes and the neighborhood level characteristics, should be removed and replaced to save water, and by contrast, what types of turfgrass should be maintained for recreational benefits. For heat mitigation, we mainly consider land surface temperature, shading structure, and social vulnerability to decide where turfgrass should be maintained or enhanced. For example, hot and vulnerable neighborhoods with low canopy coverage should be prioritized for maintaining turfgrass and adding trees. And for stormwater mitigation, we consider flow accumulation and other factors such as the land use. And similarly, we have a second activity to ask you what types of turfgrass should be maintained or enhanced to mitigate heat or stormwater. Additionally, in the last activity, we will ask you to vote on which objectives we have discussed so far that you feel are the most important to consider for the changes to made for the existing turfgrass. This table is just a summary of available data to model different turfgrass attributes we discussed before. We only incorporate attributes into modeling where the data is available, but we welcome input on other factors based on available data we haven't identified. For the second goal of today's workshop, we aim to co-produce the landscape alternatives to replace or enhance the existing turfgrass areas based on the multifunctionality and the water use efficiency. Accordingly, in our activities 3, we will ask your input on replacement scenario to achieve saving water while maximizing recreational benefits, or enhancement scenario to achieve heat mitigation or stormwater management. We include tree species choices, density and spacing options, and other design elements for both turfgrass replacement and enhancement scenarios for your considerations. Here, regarding potential changes to existing turfgrass, we would like to emphasize the enhancement scenario, which is adding trees above the existing turfgrass with mid to high functions and moderate water use. This enhancement scenario is a water-saving strategy that has been supported by the fieldwork from Dr. Liebeck's team. As you can see from the figure on the right, field-based measurements show turfgrass with tree canopy shading actually require less irrigation compared to sun-exposed turfgrass. And another significant benefit of coupling turfgrass and the trees together is to produce more enhanced cooling performance. Here we provide 5 tree species that can be added to the lawn for the enhancement scenarios. These are commonly listed species in different municipal shading programs or landscape guidelines developed by the organizations like M1 and Casca. We have included them in the posted notes in the Activity 3 for your selections, but if you have other recommendations, welcome to write it down on the blank posted notes. And similarly, we have 5 commonly recommended species in the desert landscaping for turfgrass replacement scenarios. In addition to species selection, the density and the spacing of trees are also critical considerations in the water estimate modeling. Here are some examples showing low, medium, and high tree density in Metro Phoenix areas that we captured using Google Maps. And here are more visual ideas of different spacing options combined with different tree densities. And accordingly, in our activity 3, you will be asked to choose your preferred options based on the visuals here for replacement scenario or enhancement scenario. And lastly, we would like to show you an example of an interactive GIS dashboard that we aim to deliver by the end of the project. After today's workshop, we will send bi-monthly updates to keep you posted, but we welcome you to reach out if you want to be involved between the workshops. The CREST evaluation survey will also ask this, but you can always reach out to Dr. Kelly Larson directly. And thanks everybody again for participating in today's workshop.